Hi everybody, and welcome to our slope video. So I just wanted to kind of talk briefly about slope and kind of how to calculate slope and figure slope out just by either having a few points or by taking a look at a graph, okay? And before we even discuss that, I want to talk about what does slope mean, okay? And slope is really talking about the steepness of a line, okay? How much it's angled up, how much it's angled down, if it's not angled at all, or if it's vertical, okay? So basically, the way we kind of see slope is from one point to another nice point, okay? And when I say nice point, a nice point is where the corners meet. So that would be a nice point. So I found two nice points, and then we're going to talk about how much you're rising to get to the other nice point. Or sometimes we say change in your height or your Y value, and how much you run. How much you run across. Or we also say the change in X value. And I like to say it like that, change in Y, change in X, because really that's talking about the difference between those two coordinates, okay? So when we're looking at the slope, all right, we represent it as M. And our slope is usually going to be the change in our Y, or the rise, over the change in X, or what we call our run. So rise over run. Another way that people typically use is when we have two sets of points. So change in Y can be some Y value minus another Y value divided by that same coordinate, but X, minus another X coordinate of the same point, okay? And that's what the Y1 and the Y2's mean, the X1s and the X2s, is we're talking about X1, Y1 being one point, and X2, Y2 being a second point. Okay, so now that we've kind of talked through that, what I always like to do is, again, I like to kind of, whenever we're given a linear line on a graph, I like to just count the boxes. So if I'm taking a look at my first example here, I'm looking at how many boxes am I going up versus how many boxes I'm going to the right. So I'm going up 1, 2, 3, 4 boxes. So my rise in this case is 4. And then I'm going to take a look at how many boxes am I going to the right. So I'm going 1, 2, 3, 4, 5. So my run, or my change in Y, is 5. So if I again have this slope equaling the change in Y over the change in X, what I'm really looking at is I'm going 4 units up and 5 units to the right. And this right here would represent my slope. Okay. Now, again, I'm talking about going up and to the right. Okay. So I'm talking about going up and to the right. And those represent positives. If I change direction, then that means to say I start to use negatives. So let's take a look at the next one. I have a nice point right here. And let me see where my other nice point is. I have another nice point right there. So to get from point, let's call it point A to point B, I have to go down. So I have to go down 1, 2 units. So I'm going down 2 units because I'm no longer going up. It's in the opposite direction. I need a negative. And I'm going 1, 2, 3 units to the right. That is still going to the right, so I am not changing that, which means my slope, which again is my change in y over my change in x, is going to be -2 because I'm going down 2 units over, I'm going right 3 units. So my slope here, I meant to do it in black, sorry. My slope here is -2/3, okay? So that is, of course, if you are given a graph, okay? What if you're not given a graph? So I'm going to actually do these examples actually as 2 different ways. I like to always show my 2 ways because actually a lot of people like my second way of doing it. So my equation for slope is m is equal to, and I had it written on top, y2 minus y1 over x2 minus x1. Okay, and you can really label it however you want. You can do first point being your x1, y1, and then your second point being x2, y2, or you can switch them around. It honestly doesn't matter as long as you keep it consistent. So x1, y1, x2, y2. And then you just plug it in. So 5 minus 2 over 4 minus 1. Well, that's going to be 3 over 3, which is equal to 1. That's your slope. Okay, now here's my way 2. For way 2, all I do is I actually list without the parentheses the ordered pairs. Okay, so 1, 2, 4, 5. And then I draw like an L, all right? And what I do then is I actually subtract everything. So 2 minus 5 is -3, and I'm going to move it over. And 1 minus 4 is -3, and then I'm going to move it down and over. So this becomes -3 over -3, which, oh my goodness, that is also 1, and that's going to be your slope. So 2 different ways of getting the same thing. I call way 2 the stack and subtract method, and then I call way 1 the traditional method. Now, does it matter which one you use? Absolutely not. It is 110% up to you. I always tell students to pick a way and go with it, okay? Whatever works for you, whatever makes the most sense to your brain. But these are 2 different strategies of getting to the same place. So let's do another example. And again, I'm going to do way 1, okay, where I label x1, y1, x2, y2, and I'm going to go ahead and do my slope is equal to y2 minus y1 over x2 minus x1. Now I have a couple of negatives there together, so I'm just going to change those to positives. -7 plus 2. And now I'm going to continue with my additions here. So I have -5, and this is my slope. Now, that's way 1. Way 2 is my stack and subtract method. I need a little bit more space in the bottom there. So I have -2, -3. I have -7, 4. So I stack them, draw my L, and I subtract them. So -3 minus 4 is a -7. -2 minus a -7 is a +5. Okay, I bring that down and over, and I bring that straight across. So now I have -7 over 5, which, ladies and gentlemen, that's still the same thing. -7/5. Keep in mind where I put the negative, it doesn't matter. Negative in the bottom is the same as having a negative in the top, which is the same as having a negative on the outside. So it doesn't really matter. All these three are equivalent. Okay, so kind of doesn't matter where you put them. Typically, we usually put it kind of either up or to the side, but again, like I said, it really doesn't matter. And that's really all we kind of need to know about how to calculate slope. The last thing that I want to talk about is I want to talk about the different kinds of slope. So if I have 4 different kinds, I should say. All right, so type 1 is having something like this. This is what we call having a positive slope. Okay, where your slope is always going to be up and to the right. Now, there is another kind of slope which goes like this, which is what we call negative slope. Basically, you're going down the hill. So here you can have either down and to the right, or you could have up and to the left. Okay. Now, the last 2 types of slope is when you're neither going up the hill or down the hill. We call that slope is equal to 0. And then the final one is when slope is going in a vertical direction, and we say that the slope is undefined. And there are multiple ways of kind of remembering all of these. My favorite personal way is doing the slope smiley face. And this is how it goes. That's positive slope. That's negative slope. That's 0 slope. And that's undefined slope. If we circle it all together, it's, well, smiley face or winky face, I guess. Okay, so that's just another way of kind of reminding yourself of the different types of slope. Like I said, it's just something, it's just kind of a shortcut to remembering the different kinds of slope. All right, hope you enjoyed the video, and I will see you next time with equations of lines.